Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories. The missing planet that could rewrite our solar system. Most people picture the solar system as a neat and orderly place. The sun sits in the middle. 8 planets circle around it in predictable paths. Everything looks organized, almost like a perfectly rehearsed school parade. But that's the problem. The universe has never been famous for following the rules. And lately, some astronomers have started wondering whether our picture of the solar system is missing a piece. A very large piece. What if there's another planet out there possibly larger than Earth and we've never actually seen it? That sounds like science fiction. The unsettling part is that the idea didn't come from imagination. It came from data. Because sometimes, as the saying goes, where there's smoke, there's fire. And the smoke started appearing beyond Neptune. Most people think of that region as empty space. It isn't. It's a vast, frozen wilderness filled with ancient leftovers from the solar system's formation. Dark, cold, and incredibly distant, but strangely organized. Imagine pulling your refrigerator away from the wall, expecting to find dust, and instead discovering an entire hidden machine running behind it. To understand how we got here, we have to go back to 1930. That was the year astronomer Clyde Tombaugh made one of the most famous discoveries in history, Pluto. Astronomers were thrilled. At the time, many scientists were searching for a mysterious planet X, a hidden world thought to explain oddities in the motion of Uranus. When Pluto was found, it seemed like the mystery had been solved. Case closed. Textbooks welcomed the 9th planet. Everyone moved on. Or so they thought. Decades later, better measurements began telling a different story. As spacecraft improved and missions like Voyager 2 refined our understanding of the outer planets, astronomers revisited the calculations. The result was awkward. Very awkward. Pluto simply wasn't massive enough. Not even close. If the solar system were a soccer team, Pluto wouldn't be the star midfielder controlling the game. It would be the intern handing out water bottles on the sidelines. The object everyone thought was the answer turned out to be far too small to explain the original mystery. Then came 2006. The International Astronomical Union changed the official definition of a planet. Pluto lost its status and was reclassified as a dwarf planet. Just like that, the solar system's 9th planet disappeared from the lineup. If Pluto had feelings, it might have said, "I didn't fail the test." They changed the rules. But the bigger question remained. If Pluto wasn't the answer, what happened to the original mystery? It never really went away. It simply moved farther into the darkness. Beyond Neptune lies the Kuiper belt, a distant region packed with icy objects, comet reservoirs, and ancient debris left over from the solar system's earliest days. And that's where things started getting weird. In 2003, astronomers discovered an object called Sedna. Its orbit was extraordinary. It travels so far from the Sun that it almost seems disconnected from the familiar structure of the solar system. According to standard models, Sedna's path shouldn't look the way it does. Yet there it was. Very real. Then more strange objects appeared. One of them was 2012 VP-113, another distant body with an orbit that raised eyebrows. And suddenly astronomers noticed a pattern. These objects weren't just unusual. They were unusual in similar ways. Their closest approaches to the Sun were surprisingly distant. Their orbits were stretched into extreme ellipses. And perhaps strangest of all, many of them seemed to point in roughly the same direction. That's when curiosity started turning into suspicion. Because randomness can produce weird things. But randomness rarely produces order. You can expect people in a crowd to walk differently. But if everyone at the edge of the solar system starts marching in the same direction, you begin to wonder who's leading the parade. Some researchers started running computer simulations to find an explanation. The results kept pointing toward the same possibility. Without some additional gravitational influence, the models struggled to reproduce what astronomers were observing. Something appeared to be shaping those distant orbits. Something large. Something unseen. Slowly, an idea began to emerge. Maybe a massive planet was lurking far beyond Neptune, hidden in the darkness. This was the earliest version of what would later become known as Planet 9. But before anyone got too excited, another problem appeared. A simple one. If this planet is real, why hasn't anyone seen it? The answer may be frustratingly straightforward. It's probably incredibly far away. It produces no light of its own. It reflects very little sunlight. And it moves so slowly across the sky that years could pass before its motion becomes obvious. Imagine trying to find a black hockey puck in a dark room. Now imagine the puck barely moves. That's the challenge astronomers are facing. And so the mystery deepened. On one side, the orbital evidence kept becoming harder to ignore. On the other, there wasn't a single direct image proving the planet exists. Between those two facts sat a giant question mark. If there's really a hidden world out there, what is it doing right now? And perhaps the more unsettling possibility is this. What if it has been there the entire time, quietly circling the sun in the darkness, while humanity simply never noticed it? Then, in 2016, the story took a dramatic turn. What had been a slow-moving scientific investigation suddenly started to feel more like a cosmic detective thriller. The turning point came from two astronomers at the California Institute of Technology, Konstantin Batygin and Mike Brown. Their original goal wasn't particularly flashy. They simply took the strange objects lurking beyond Neptune, fed their orbital data into computer simulations, and tried to figure out why so many of them seemed to be behaving in surprisingly similar ways. What happened next caught everyone's attention. The simulations kept pointing toward the same answer. And the answer was unsettling. It was one of those moments where scientists look at a result and think, this can't be right, but what if it is? In their 2016 paper, Batygin and Brown proposed a bold possibility. What if a massive undiscovered planet was orbiting far beyond Neptune? Not a Pluto-sized object. Something much larger. Perhaps 5 to 10 times the mass of Earth. According to their calculations, a planet like that could naturally explain why so many distant objects appeared strangely organized. Eventually, the media gave it a memorable name, Planet 9. But here's the important part. Planet 9 wasn't discovered through a telescope. Nobody saw it. Nobody photographed it. Nobody measured its light. It emerged from mathematics. Or more accurately, it was dragged out of the equations kicking and screaming. The hypothetical planet itself sounded almost absurd. Its orbit could stretch hundreds or even thousands of astronomical units from the Sun. A single year on Planet 9 might last 10,000 years or more. And yet, from a physics standpoint, the idea made remarkable sense. Imagine the solar system as a giant stage play. The known planets are the actors everyone can see. Planet 9 would be the person backstage pulling the strings. Never appearing in the spotlight, still influencing everything. Some astronomers jokingly referred to it as the solar system's invisible drill instructor, the one keeping distant icy worlds lined up and behaving themselves. But if you expected the scientific community to unite behind the idea, that's not what happened. Quite the opposite. The debate intensified. Supporters argued that the orbital alignments were simply too orderly to be random. Skeptics countered with an obvious question. Are you discovering a planet, or inventing one to explain a mystery? And honestly, that's a fair criticism. Science has always been cautious about explanations that solve one problem by introducing something nobody has actually observed. Still, one fact refused to go away. The model worked. When Planet 9 was included in simulations, many of the puzzling orbital patterns emerged naturally. When it was removed, the models became messy. Researchers suddenly needed additional assumptions, extra interactions, and increasingly complicated scenarios to reproduce the same results. As the saying goes, if you hear hoofbeats, think horses before zebras. To some scientists, Planet 9 looked like the horse, a relatively simple explanation for a complicated set of observations. The idea quickly spread through the astronomy community. Researchers began debating whether these orbital alignments represented genuine gravitational structure or merely statistical coincidence. At first, the discussion remained mostly academic. Then the public got involved. Because unlike many scientific debates, this one was surprisingly easy to visualize. You didn't need a PhD in orbital mechanics. You could simply look at diagrams of these distant objects and notice something odd. Many of them seemed to be pointing in similar directions, almost as if they were orbiting around the influence of something hidden. Slowly, Planet 9 transformed from a mathematical possibility into something that felt almost tangible. People began imagining it as a frozen super-Earth, a dark world wandering far beyond Neptune, a planet detected not through light, but through gravity, a world revealed by the fingerprints it left behind. But that created an even bigger problem. If it exists, where is it? Unfortunately, the answer isn't encouraging. Planet 9 seems perfectly designed to avoid discovery. Current estimates place it somewhere between roughly 200 and 1,200 astronomical units from the Sun. At those distances, sunlight is incredibly weak. Any reflected light would be faint, very faint, and its motion across the sky would be painfully slow. How slow? Take a photograph today. Take another one 5 years later. The planet might have barely moved. Trying to find it is like searching for a charcoal-colored pebble in a dark stadium at midnight. You know it could be there. You just don't know where to look. Astronomers have already searched enormous portions of the sky. NASA's WISE mission scanned the heavens in infrared light and ruled out several possibilities. But there was a catch. WISE is particularly effective at finding warm objects. Planet 9, if it exists, would be extraordinarily cold, almost invisible. So WISE narrowed the search without eliminating it, which leaves us in a strange position. We're not looking blindly anymore, but we still haven't searched the most promising hiding places thoroughly enough. And that's where the story becomes even more interesting. Scientists are increasingly relying on indirect evidence. Instead of trying to see the planet itself, they're studying the marks it may have left behind. Because the deeper researchers examine the Kuiper belt, the more they notice subtle patterns. Certain orbital directions appear clustered. Some orbital tilts seem oddly coordinated. It's a little like watching runners on a giant circular track and realizing that nearly everyone is drifting slightly in the same direction. Something appears to be nudging them. Simulation after simulation points toward the same conclusion. Add a distant massive planet, and those patterns emerge naturally. Remove it, and alternative explanations become increasingly complicated. Maybe passing stars disturbed the outer solar system billions of years ago. Maybe multiple stages of gravitational evolution produced the effect. Maybe we're seeing an extremely unlikely statistical fluke. All of those explanations are possible, but they require more moving parts. Planet 9 remains surprisingly elegant, perhaps a little too elegant. In fact, some researchers have pointed out an unusual concern. The model works almost too well. And in science, that's not always a compliment. Sometimes an explanation fits because it's correct. Other times it fits because you've unknowingly built a mathematical ghost. An idea so flexible that it starts explaining everything. Yet there's a reason the hypothesis refuses to disappear. The evidence isn't based on a single object or a single observation. It's a recurring pattern, a collection of gravitational clues that keeps showing up, again, and again, and again. Which leaves us with a fascinating question. Are astronomers using an imaginary planet to explain the data? Or are the data slowly leading us toward a real world waiting to be found? Because after all these years, Planet 9 occupies a very unusual place in science. It works on paper. It works in simulations. It explains real observations. And yet, despite all of that, it remains completely invisible. Once Planet 9 entered the public spotlight, the mood in astronomy changed. Not in a we're all solving this mystery together kind of way. It felt more like a room full of experts staring at a locked box. Some were convinced it contained treasure. Others insisted it was empty. And a third group kept saying, "Hold on. Let me run the numbers one more time." On one side stood Planet 9's most well-known supporters, Konstantin Batygin and Mike Brown. Their argument has remained surprisingly consistent over the years. The strange objects far beyond Neptune don't appear randomly distributed. Bodies like Sedna and 2012 VP-113 seem to share orbital patterns that are difficult to dismiss as pure coincidence. As more observations came in, the models were refined, updated, and tested again. Yet the same basic picture kept emerging. The supporters' reasoning is straightforward. If you keep finding the same pattern, eventually you have to ask whether something is creating it. But science isn't decided by a show of hands. And the skeptics were never short on counterarguments. Interestingly, most critics weren't saying Planet 9 definitely doesn't exist. They were asking a different question. What if we're misreading the evidence? One of the biggest concerns involves observational bias. The objects in the outer solar system are incredibly faint. Astronomers can only search certain parts of the sky at certain times, which creates a potential problem. Maybe the apparent clustering isn't a property of the universe. Maybe it's a property of where we've been looking. As the saying goes, you can't find what you never searched for. A second criticism focuses on sample size. The number of extreme distant objects available for analysis is still relatively small, and small datasets can be deceptive. Flip a coin 10 times and get 7 heads. For a moment, you might start wondering whether the coin has a favorite side. Statistics can play tricks on us that way. Then there's an even more intriguing possibility. Some researchers argue that no giant hidden planet is required at all. Over billions of years, countless weak gravitational interactions may have gradually shaped the outer solar system. Combine that with leftover structures from the solar system's formation, and you might create the illusion of organization without any unseen planet pulling the strings. In other words, what looks like a hidden conductor could simply be the orchestra tuning itself. Other alternative explanations have been proposed as well. Perhaps a passing star brushed by the young solar system long ago. Perhaps planetary migration left behind subtle gravitational scars. Perhaps several unlikely effects happen to overlap. None of these ideas are impossible. The trade-off is that they tend to be much more complicated. And that's where the debate becomes fascinating. One side sees elegance in a single unseen planet explaining multiple mysteries. The other sees danger in a solution that may be too simple. Same data, very different conclusions. It's one of those moments that reminds us science is not just about facts. It's also about interpretation. As the years passed, the discussion became almost philosophical. Some researchers argued that direct observation is the only thing that matters. Others felt the dynamical evidence was becoming too strong to ignore. And many quietly continued running simulations, waiting for the data to settle the argument. If we're being honest, the current situation can be summarized like this. Some scientists think Planet 9 is real. Some think it isn't. And many are still saying, give us a little more time. Yet everyone agrees on one thing. No explanation currently accounts for every detail perfectly. There's always a loose thread somewhere. A tiny gap. A stubborn gap. And that gap is exactly what launched the next phase of the search. Astronomers stopped debating where Planet 9 might be. They started actively hunting for it. One of the earliest major tools was NASA's WISE mission. During the 2010s, it scanned the entire sky in infrared light, searching for faint objects, brown dwarfs, and other hidden residents of our cosmic neighborhood. WISE never found Planet 9, but it accomplished something almost as important. It ruled out several possibilities. Large, relatively warm planets lurking nearby became increasingly unlikely. The mystery was pushed farther into the darkness. Much farther. Then ground-based observatories joined the hunt. The Subaru telescope in Hawaii began surveying deep regions of the sky with extraordinary sensitivity. Meanwhile, projects like the Dark Energy Survey, originally designed to study the expansion of the universe, ended up collecting valuable data on distant solar system objects as well. Little by little, the search area shrank. Not enough to reveal the answer, but enough to make the mystery even more compelling. We're no longer asking whether Planet 9 could be anywhere. We're beginning to identify where it might be hiding. And then comes what many astronomers consider the most exciting chapter yet, the Vera C. Rubin Observatory. This telescope has a simple but powerful advantage. It won't photograph the sky once. It will photograph it again, and again, and again, over and over. Why does that matter? Because a distant object can hide in a single image. It can't hide forever in thousands of them, even if it moves only slightly from year to year, even if it's incredibly faint, even if it spends its entire existence pretending not to be there. Astronomers sometimes joke that Planet 9 may eventually get caught simply because it's moving too slowly to escape repeated observations. It sounds funny, but that's actually the strategy. And beneath all of this searching lies a deeper realization. For the first time, humanity isn't merely cataloging objects in the solar system. We're probing the limits of the solar system itself. Because if Planet 9 is eventually confirmed, the consequences could be enormous. Models of planetary formation may need revision. Our understanding of the Kuiper belt could change. Even the question of where the solar system truly ends may become less clear than we thought. After all, it's hard to claim a system is complete when one of its largest members may still be missing. In a strange way, astronomers may have spent decades studying a draft version of the solar system, a map that looked finished, but wasn't. Sometimes researchers joke about it in a surprisingly simple way. The solar system thought it had everybody accounted for. Then someone checked the attendance sheet, and one name might still be missing. Yet the deepest mystery remains unresolved. If Planet 9 is real, where is it right now? And if it isn't real, why do so many distant objects behave as though something is organizing them? And above all those questions hangs one final thought. Quiet, uncomfortable, hard to shake. What if that distant world really is out there, circling far beyond the reach of our telescopes? What if it has spent all this time hidden inside one of astronomy's biggest blind spots? And what if, after all these years of searching, we've been looking almost directly past it? The people who change the world usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.